Hi guys, greetings to you all. Today we're looking at the limit at infinity. The limit at infinity. Looking at the limit of a function at infinity. Okay. Now we'll start by understanding the concept. What is positive infinity? What is positive infinity? When you talk about the limit at infinity, what is positive infinity? And to do that, let's look at this. To demonstrate this, let's do the following. Okay, let's take 1000 here divided by 1. We have 1000. 1000 divided by 0.1, we have 10,000. That same 1000 divided by 0.01, we have 100,000. That same 1000 divided by 0.01, we have 1 million. And that same 1000 divided by 0.001, we have 10 million. So what do you notice? You notice that positive infinity, you can conclude that positive infinity is a positive number divided by 0. Positive infinity is a positive number divided by 0. Because as you can see here, as the denominator is approaching 0, you have same number 1000 divided by 1. You see that is 1000. 1000 divided by 0.1, 10,000. 1000 divided by 0.01, 100,000, and so on till we are here at 10 million. If you divide by 0.0001, you'll be talking about 100 million, and you'll be growing as it is approaching. When you divide by a very small number which is approaching 0, the number is becoming large and large. And as it's becoming very large, that's why we bring in the concept of positive infinity. Okay. Likewise, a negative number divided by 0 gives us negative infinity. Okay. Equally, what is a number? When a number is divided by infinity, what do we get? When a number is divided by infinity, what do we get? Okay, to demonstrate that, we'll start with this. We have 1 divided by 2. If you have 1 loaf of bread to share to 2, each person will have half. Now, that same loaf of bread, if you share to 1000, you have 0.001. Okay, you now see that it is becoming very small as the number of people that you are sharing is increasing. You have shared by 2, you have 0.5. You have shared by 1000, you have 0.001. Now, if you share by 1 million, you have 0.0001. What is happening? You see that as the denominator is increasing, as the denominator is tending towards infinity, as the denominator is increasing, tending towards infinity, the answer is turning to approaching 0. So our conclusion, any number divided by infinity gives us 0. Any number divided by infinity is 0. So that's it. we'll look at examples of limits at infinity. Example 1, find the limit as x tends to positive infinity of x squared minus 2x plus 3. X squared minus 2x plus 3. Solution. Here we'll look at a very short approach to obtain this limit. The limit, this is a polynomial. The highest power is 2, that is degree 2. So instead of substituting positive infinity here, positive here, and to all the 3 terms, the limit of a polynomial at infinity is simply the limit of the term with the highest power. Like all of these limits will just be the limit as x tends to positive infinity of x squared, right? Which gives us positive infinity. Okay, let's look at another example. Example 2, find the limit as x tends to positive infinity of negative 3x cubed minus 2x squared plus 3x minus 4. Okay, let's have our solution. Now, this shorter approach, this short trick that I want to show you, looking at this limit here, we have here cubic. Instead of substituting positive infinity throughout, what are we going to do? The solution will simply be the limit of negative, the highest power here is x cubed, so it will just be the limit as x tends towards negative infinity of negative 3x cubed. Okay, sorry, here should be negative infinity. Yes, negative infinity. Thank you, negative. So we have here negative infinity. If you substitute here, we are going to have negative here, which gives us positive. Okay, now a negative there, positive infinity. All right, let's look at the third example. Evaluate limit as x tends to positive infinity of x plus 3 divided by x minus 2. This one is a rational function, and as a rational function, here we still have another trick, another approach which permits you, normally instead of dividing the numerator and the denominator by the highest power of x, that is divide here x over x plus 3 over x, here x over x minus 2 over x, before evaluating the limit. Here is a very short approach which is very accepted and gives us the same answer. Now, a degree, I will divide by the highest degree here, taken together plus the coefficient x, and here x, the numerator, the highest power here is x to the power 1 also, so x. So the limit as x tends towards positive infinity, x over x, which x divided by x here is 1. So the limit of 1 as x tends towards positive infinity. Now the limit of a constant is a constant. Despite the value as x tends to positive infinity, the limit of a constant gives us a constant, that's 1. Okay. Now let's look at example 4. Find the limit as x tends to positive infinity of 2x squared plus 3x minus 2 divided by 5x cubed minus 2x squared plus 2x minus 2. Let's have our solution. Yes, what do you think we can do at this stage concerning our shorter approach? Here we have 2x squared. The term with the highest power is 2x squared at the numerator. The term with the highest power is 5x cubed. So we have 2x squared now divided by 5x cubed, which when we simplify, it gives us x squared cancel, it gives you 2 over 5x. Now the limit as x tends towards positive infinity will simply be 2 divided by 5 times positive infinity, which is positive. 5 times positive infinity is still positive infinity. So 2 over infinity, 2 divided by infinity gives us 0. So instead of dividing here by x cubed all through by x cubed all through these 4 terms by x cubed, we simply look at the term with the highest power of the denominator. We look at the term with the highest power, the term with the highest power of the numerator. This is it. The term with the highest power of x at the denominator, which is this, and we evaluate the limit. Okay, let's move to the next example. Example 5. Find the limit at x tends to infinity of 2x cubed plus 3x minus 2 divided by 5x squared minus 2x plus 2x minus 2. Okay, this is a repeated term. This should read 2x here plus 2. Now, when we are to solve that, we have here, what's the power? We use same approach. What's the term with the highest power is 2x cubed. Okay, I just correct. I said this should read 2x plus 2 minus 1 minus 2 plus 2 minus okay, so we have here the limit will simply be limit as x tends towards infinity. It will just be 2x cubed all over which will be equal to the limit of 2x cubed divided by 5x squared. Alright, which gives us 2. When you cancel, you have 2x over 5, the limit as x tends towards infinity. And if you substitute here at the numerator, infinity, 2 times infinity is infinity. Infinity divided by 5 is infinity, which gives us infinity. Instead of the approach of dividing all through by x cubed, the numerator by x cubed, or for all terms, the denominators for all terms. Alright, thank you for watching. Please don't forget to like, subscribe, share. See you in the next video.